Hi guys, welcome to my channel. In this video, I'll be covering complete Unit 1 in Cloud Computing subject. I will explain each and every topic in detail, and whatever the topics that I'm going to cover in this video, I will provide all those topics and the timings in description. Before starting this video, please check in description. Guys, I have uploaded a complete Cloud Computing subject tutorials. I will provide that link in description. You can watch from there. Guys, I will provide this Cloud Computing handwritten notes in description. You can download from description. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Let's get started. At first I will explain what is high performance computing. But before that, you need to know what is computing. Guys, computing is nothing but using computers to perform certain tasks is known as computing. So we will use computers to perform certain tasks. This is known as computing. Now I will explain what is high performance computing. High performance computing refers to the use of multiple processors working together with the resources such as memory, storage, input-output devices to solve complex and large-scale problems. Guys, in high performance computing, we will use multiple processors. If you use multiple processors, then our computer will be fast. I will give an example. For example, let us say this is my computer and this is my CPU. My CPU contains multiple processors. These processors are connected to motherboard. So if there are multiple processors, my computer will be fast. And the CPU contains memory and storage, that is nothing but hard disk and RAM, and also it contains input and output devices like printer, keyboard, mouse, speakers, etc. By using all these resources, we can solve complex problems. So in high performance computing, we'll use multiple processors with the resources like memory, storage, input output devices, etc. in order to solve large scale problems. This is known as high performance computing. Guys, in high performance computing, processors can be either of same type or different type. If they are of same type, then we call it as homogeneous processors, and if they are of different type, then we call it as heterogeneous processors. For example, let us say inside my CPU there are 4 processors. All these 4 processors are Intel 8 core processors. So this is Intel 8 core. This is also Intel 8 core processor, this is also Intel 8 core, and this is also Intel 8 core. So all these are of same type. So if all processors are of same type, then we call it as homogeneous processors. For example, let us say now inside my CPU there are 4 different type of processors. All are not of same type, all are different type. Then we call it as heterogeneous processors. In past, when you talk about high performance computing, we usually mean supercomputers, which are very powerful machines used for heavy calculations. Now high performance computing also includes smaller systems like regular computers like desktops, PCs, etc. These are found in places like schools, offices, etc. Guys, in olden days, high performance computing mean only supercomputers. There are no other computers. Only by using supercomputers we can perform high calculations. But whereas at present, even our regular computers like laptops, desktops, etc. we call all these computers as high performance computers. Guys, in science, for complex problems, you need to perform lot of calculations. For example, let us say protein folding. Guys, protein folding is the process of how protein takes shape. So if scientists understand this, then they can develop new medicines. So for protein folding, we need high performance computing in order to perform lot of calculations. And next scientific task is nuclear fusion models. Guys, nuclear fusion is nothing but we will generate energy by using sun. So even for this process, scientists must perform lot of calculations. So for this they need high performance computing. So normally by using our regular computers, we cannot complete complex tasks. So for this large scale problems, we need high performance computing. And high performance computing is nothing but in our system we will use multiple processors in order to perform these complex operations. High performance computing enables faster and more efficient problem solving by using combined power of multiple computers. Guys, multiple processors are like multiple computers working together in order to handle complex operations that cannot be handled by single computer. Whenever user give big data or big task to this high performance computing, this big data is shared among multiple processors. This multiple processors will solve a problem and then it will give result to the user. This is structure of high performance computing. Next I will explain what is parallel computing. Parallel computing is when multiple processes work together at the same time to solve one big problem. All the processes are usually similar and connected to each other. For example, let us say I'm user. I give a big problem to this computer. And this is parallel computing. That is nothing but inside this computer there are multiple processors and all these processors are of same type. Guys, in parallel computing we will use multiple processors and all these processors are of same type. So whenever I give big problem, this big problem is shared among multiple processors. Guys, I will give one real-time example so that you can clearly understand. For example, let us say college faculty give one task to student. The task is to create C material, Python material, Java material and C++ material. So at first student will create C material. For example, it will take 1 day of time, and similarly next day student will create Python material, another 1 day of time, and next another day Java material, another 1 day of time, and next C++ material. So it will take approximately 4 days of time. So one student is same like one processor inside computer. Now what faculty will do is, faculty will select 4 students. So in order to create 4 materials. So now faculty will give task to 4 students in order to create 4 materials. So these are like multiple processors. If there are multiple processors, then work will be shared among these processors and then our work will complete faster. This is parallel computing. Parallel computing is nothing but we'll use multiple processors in order to solve one big problem. So big problem is nothing but we need to create 4 study materials. This is big problem. So now task is shared among multiple processors in order to solve one big problem. Serial computing is like doing things step by step. A single processor does one instruction after another. I already said this example. If there is only single person, then at first he will create C material. Only after creating C material, then he will start Python material. So he will complete work step by step manner. So single person is same like single processor. Only if there is one processor, that processor will complete work in step by step manner. So only after completing first instruction, then it will go to second instruction. So in serial computing, we will use only one single processor in our CPU. And we also call this serial computing as sequential computing. In parallel computing, we will use multiple processors. That processors will work together in order to solve one big problem. And all these processors are of same type. That is nothing but all these processors are of homogeneous type. One of the example is supercomputers. In supercomputers, there will be thousands of processors connected together in order to solve complex problems. Guys, if you use parallel computing, it will save time and money, because if you use multiple processors at a time, then your work will complete faster, and instead of purchasing multiple computers, you can purchase only single computer with multiple processors. So multiple processors are same like multiple computers, which will complete work faster. So it will save time and money. And next one is solve bigger problems. So if there is any large problem, this large problem is shared among multiple processors in order to solve that large problem. And third advantage is, does multiple things at once. In serial computing, only after completing first task, it will go to second task. But whereas in parallel computing, so tasks are shared among multiple processors. So a single computer can do only one thing at a time. But with parallel computing, multiple computers can work together on different tasks at the same time. And fourth advantage is, uses resources from different places. Guys, in parallel computing, if our computer is busy, then we can also use other computers from different places by using internet. Next I will explain what is computational grid, or we also call it as grid computing. A computational grid is a system made of both hardware and software that allows many computers to work together. It gives reliable, consistent and low cost access to powerful computing. Guys, I will give an example so that you can clearly understand what is grid computing. For example, let us say there are 4 computers. This is computer which is located in Hyderabad, and this is another computer which is located in Delhi, and this is laptop, and this is another computer. This is located in Bangalore, and this is located in Goa. So in computational grid, all these computers are connected to each other through internet. And not only internet, if all these computers want to communicate with each other, they need to install one common software. So common software must be installed in all these computers in order to communicate between each other. So whenever big task is given, This big task is divided into smaller subtasks. These tasks are shared among multiple computers by using this common software. And even if one system fails, remaining systems will work. These are advantages of computational grid. And the first one is reliable. Reliable is nothing but even if one computer fails, remaining computers will work. And next one is consistency. As work is shared among multiple computers, performance will be good. And third one is low cost. Instead of purchasing one expensive big computer, we can purchase smaller computers in cheap rate and then we can connect to those computers and we can use. So which will save our money. In computational grid, many computers are connected in network to share work. In computational grid, all computers are connected to each other by using internet and they will share work among themselves. A big task is broken into smaller subtasks and each computer works on the one part of the task at the same time. Guys, all computers will perform work at the same time. So it will save our time. And after finishing, each computer will send result back to the main computer. These computers may also belong to different organizations or locations. It is not mandatory that all computers must be in one place. These computers may also located in different locations. This is example, laptop, desktop and supercomputers and database. All these are connected to each other by using internet. And they will share work among themselves. For example, after completing work, this data is stored in database by using internet. Next, I will explain what is distributed computing. Distributed computing is a system where multiple computers work together as if they are like one single computer. These computers can be closer together, connected by local network or far apart, connected through the internet. And there can also be different types of computers such as desktops, laptops, large machine servers, etc. Guys, parallel computing and distributed computing both are different. In parallel computing, inside CPU we will use multiple processors. But whereas in distributed computing, we will use multiple computers and all these computers are connected to each other by using internet or cable. And these computers can be of any type like laptops, desktops, servers, etc. And the main goal of distributed computing is to make all computers work together in order to solve problems faster and efficiently. Distributed computing is like dividing big tasks among multiple people instead of giving complete work to a single person. These are advantages of distributed computing, and the first advantage is scalability. Guys, in distributed computing, you can easily add or you can also easily remove computers. For example, if there is big work, then we can add multiple computers. And if there is less work, then we can also remove computers. So based on our work, we can easily add or remove computers without disturbing our current work. So it makes easier to handle more work as system grows. And next one is redundancy. In distributed computing, we'll use multiple computers in order to perform certain tasks. So even if any computer fails, remaining computers will work. So problem in one computer will not affect other computers. Still work will complete. So this setup makes computing more flexible, reliable and faster. Flexible is nothing but we can add or we can remove systems if needed. And reliability is nothing but even if one computer fails, remaining computers will work. And we can connect all those computers by using internet or even by using cable. Next I will explain difference between parallel computing and distributed computing. Guys, in parallel computing, in our CPU there will be multiple processors and processor will share work among themselves. And whereas in distributed computing, a single task is distributed among multiple systems. In parallel computing, we will use only one single computer. Inside the single computer, there will be multiple processors. And whereas in distributed computing, there are a lot of computers involved. Parallel computing consists of multiple processors in order to perform multiple operations. And whereas in distributed computing, multiple operations are performed by multiple computers in a distributed environment. Parallel computing supports shared and distributed memory, and whereas distributed computing supports distributed memory. And whereas in parallel computing, bus communication mechanism is used for communication, and whereas in distributed computing, message passing mechanism is used for communication. As there are multiple processors inside single computer, system performance can be improved in parallel computing. And whereas in distributed computing, fault tolerance, that is nothing but even if one computer fails, remaining computers will work. And next one is system scalability. We can add or we can remove systems based on our need. And next one is we can also share resources like printer, scanner, etc. So all these are improved in distributed computing. Guys, in parallel computing, scalability and fault tolerance is less. And whereas in distributed computing, there will be high scalability and fault tolerance when compared to parallel computing. In parallel computing, a single computer will manage all operations. And whereas in distributed computing, all computers coordinate with each other by using advanced mechanisms. These are differences between parallel computing and distributed computing. Guys, these are advantages of distributed system over centralized system. Centralized system is nothing but one main system which will perform all operations. And the first advantage is economics. Instead of purchasing one high configuration system, you can purchase many small computers which are cheaper. And next advantage is speed. When compared to single computer, distributed systems has more computing power, so they can complete tasks faster. And third advantage of distributed system is inherent distribution. Guys, some applications are spread over many locations. For example, if you consider supermarkets like DMart, that supermarkets are present in many locations. So for such kind of systems, distributed system is good choice. And fourth one is reliability. In distributed systems, even if one computer fails, remaining computers will work, so we can complete task. And fifth one is incremental growth. Guys, for example, if there is any big task, then you can also add computers in order to perform those tasks. And these are disadvantages of distributed system over centralized systems. And the first one is software. Guys, if you want to connect many computers in different location, we also need software. So developing such software is very tough. And next disadvantage of distributed systems is network issues. In distributed systems, we will connect various kinds of systems in different locations. Either we can connect by using cable or internet, so there is high chance for network issues. And next disadvantage is security. As many computers are connected to each other, keeping data secure is very tough. Next I will explain what are distributed system models. Distributed system models are made up of many independent computers called nodes that works together. Guys, in all distributed system models, we will connect multiple computers together and we call these computers as nodes. And these nodes are connected through different type of networks like storage area networks, local area networks and wide area networks. Guys, in storage area network, we will connect multiple computers with multiple servers for storage purpose. Like you can store data or you can access data through servers. We call it as storage area network. Guys, for example, let us say there is one company in Hyderabad. In that company, in first floor, many computers are connected together. If all computers are connected together within short range, then we call it as local area network. Guys, for example, let us say there are two companies. One company is in Hyderabad location and next company is in Bangalore location. Now if we establish connection between these two companies, then we call it as wide area network. Guys, in LAN, we can easily connect hundreds of computers and we call that group as cluster. For example, let us say this is one cluster and this is one cluster. And if we connect multiple local clusters, then we call it as wide area network. For example, let us say this is one local cluster and this is one local cluster. If we connect these two clusters, then we call it as wide area network. And in wide area network, we can connect millions of computers. And in all these three networks, connection can be either wide or wireless. Guys, these are various distributed system models. And the first one is clusters of cooperative computers, or we can also call it as cluster computing. This is a group of standalone computers that works together like a single computer. They share resources like storage and are connected by high-speed networks like SAN or LAN. Guys, in cluster computing, all computers are connected to each other and they will work like a single computer. And in cluster computing, connection can be either storage area network or local area network. They can also share resources like storage. For example, I can easily store data in this server. So in cluster computing, we can also share resources like storage. And second one is grid computing. Grid computing combines resources from different organizations to provide computing power or data services. It can be divided into two types. First one is computational grid and next one is data grid. Guys, difference between cluster computing and grid computing is, guys, in cluster computing, single task is shared among multiple computers, whereas in grid computing, each task is given to one computer. And cluster computing is storage area network or local area network, and whereas grid computing is wide area network. The name itself says Computational grid. Computers in different locations are connected to each other for computing purpose. That is nothing but in order to perform various tasks. Computers in various locations are connected to each other for sharing and managing data. This is data grid. And third distributed system model is peer-to-peer model. In a peer-to-peer system, every computer acts both as a client and as a server. All machines can join or leave the network freely. Computer which want information is known as client, and computer which provide information is known as server. So now this computer will provide information to this computer. Now this computer act as client and this computer act as server. Whereas client want information and server will provide information. And in peer-to-peer model, all computers act as both client and servers. So all machines can join or leave network easily. And fourth one is overlay network. An overlay network is a virtual network created on top of an existing network. For example, let us say there are 4 computers connected to internet. So this is actual network. Now these both computers are connected to each other using internet in order to play online games. Now inside actual network, these 2 computers created virtual network in order to play games. This is an example of overlay network. Next I will explain what is cluster computing. A computer cluster or cluster computing is when several computers called nodes are connected together to work as one powerful system. These computers are usually the same type and they are linked through a network. They share resources like files and have special software that helps them to work together on the same task. Guys, I will give an example so that you can clearly understand this definition. Guys, in cluster computing, several computers are connected to each other and we call this each computer as node. Node computer, both are same, and all these computers are of same type and all these computers are connected to each other through network. Network is nothing but establishing connection between computers. Either it can be wired or wireless. This is known as network. Mostly cluster computing is local area network. And in cluster computing, each and every computer has separate software in order to communicate between each other. And they can also share resources like files. Like they can easily transfer files from one system to other system. And all these computers will work on the same task. This is known as cluster computing. For example, if there is any big task, one computer cannot solve that big task. So that big task is shared among multiple computers in cluster computing. So this cluster computing is part of high performance computing because they can solve large problems. And in order to solve large problems, all computers must communicate between each other. So each and every computer is connected to each other through network. Either it can be wired or wireless. And in cluster computing, all computers are of same type. And in cluster computing, if all computers are of different type, then we call it as heterogeneous cluster. For example, one computer is laptop with high storage, high hardware and software, etc. And whereas another computer is small computer with basic software and hardware. And this heterogeneous cluster is specialized version of cluster computing. Mostly researchers will use this. These are various design principles of cluster computing, and the first one is single system image. Shortly we call it as SSI. Cluster is nothing but group of computers working together in order to solve one task. So when you use cluster, that is nothing but group of computers working together, then it looks and behaves like a single computer. Even though if it has many processors or computers, it will look like single computer. This is meaning of SSI. And second one is single job management system. All the jobs in the cluster are handled by one central system. And you can submit task from any computer in the cluster. Guys, in cluster computing, there will be one centralized system. It acts like main system. So it will distribute task among multiple computers. So after completing task, so you can send this result back to this main computer. And third one is single user interface. You access the cluster using a single, easy to use graphical interface like the desktop or your computer. Guys, in cluster computing, each and every computer contains one separate software. So work done by each and every computer is seen in that software. So it is like single user interface. And fourth one is reliability, availability and serviceability. Reliability means how long the cluster can run without failing or breaking down. In cluster, all computers are connected to each other. So there may be some service problem. So how long cluster can run without failing is known as reliability. How much time particular system is working and how much time system is available. This is known as availability. For example, if we give any task, the system must be available. And next one is serviceability. How easy to fix, maintain or upgrade the cluster. For example, if there is any problem like network issues, then we must easily fix and upgrade the cluster. This is meaning of serviceability. These are principles of cluster computing. And next I will explain objectives of cluster computing. Guys, we also call this cluster computing as computer cluster. First objective is scalability. If needed, we can also add more computers to our cluster. So scalability means you can grow or expand the cluster by adding more computers to it. We call these computers as nodes. And second objective is packing. Packing is nothing but connecting. In cluster computing, all computers are connected to each other tightly. So if all computers are stored in one particular location and connected tightly, then we require more cooling to control heat. So that is why sometimes different computers are placed in different locations in order to reduce heat. But if all computers are in different locations, connecting those computers is very complex task. Third objective is control. In cluster, if one system controls all the computers, then we call it as centralized cluster. It is like one boss, which will share each and every operations to all computers. And whereas in decentralized control, there will not be any central system in order to control remaining computers. And fourth one is homogeneity. That means all computers are of same type in terms of hardware and software. And fifth one is security. In cluster computing, all computers are connected to each other through network. So we must keep data secure. So if there is no security, then we call it as exposed cluster. Next I will explain what is grid computing. Grid computing is a distributed computing model that connects multiple computers or servers across different locations to work together as a virtual supercomputer. Guys, in grid computing, we will connect to multiple computers and servers, and all these computers and servers are from different locations. Basically, all these are connected through internet, and multiple computers and servers together act as a virtual supercomputer. Many organizations have computers that aren't being used fully all the time. Grid computing takes this unused power from different computers and allows other organizations or users to borrow it to perform tasks. This increases the value of their investment. Guys, for example, I want 1000 GB of data in order to store my files. But in my laptop, 1000 GB of space is not available. And for example, there is one big company. In that company, there are so many servers, and the servers are unused. So with very less cost, I can borrow the servers and I can store my data. Guys, borrowing is not like physically you are taking the server to your house. Borrowing is nothing but by using internet, I will store my information in the server. So instead of purchasing one big server, by using internet, I will store my 1000 GB files in the server, which will save my money. And if you want to connect to the server in your laptop, you need to install one software called middleware software. So in grid computing, in order to establish connections, you need middleware. Middleware is nothing but it is a software. A special software called middleware connects many computers or servers across different locations. The middleware also controls access to the shared computers, provides security, and gives user access to files, data, and large storage remotely. Guys, this middleware software also gives access control. For example, as I said before, I want to store 1000 GB of data in the server. So in the server, I will purchase only 1000 GB of space. So it will give access only to 1000 GB of data. For example, if I store 5000 GB of data, it will not accept. These are advantages of grid computing, and the first one is cost efficient. Guys, in grid computing, we will use unused computers. If any computer is free in organization, we will borrow it instead of purchasing new computer. So which will save our money. And second one is high performance. In grid computing, multiple computers and as well as multiple servers are connected to each other. So we can solve complex problems. And third one is collaboration. Different computers can work together smoothly to solve common tasks. We can easily connect one computer to another computer in order to solve tasks. Next I will explain what is cloud computing. Cloud computing is the delivery of IT resources like servers, storage, databases, networking, software over the internet. Instead of buying and managing physical hardware or software, user accesses these resources remotely from the cloud providers like AWS, Microsoft Azure, Google Cloud, etc. It's like renting services when you need them and you pay only for what you use. Guys, I will give an example so that you can clearly understand what is cloud computing. Guys, AWS, Google Cloud and Microsoft Azure. These three are famous companies that will provide cloud services. These companies will give hardware, software, databases, servers, etc. for rent. I'll give an example. For example, there is one user. This user wants to store 2000 GB of data in server, but buying server is costly. At that time, what this user will do is, this user will open internet. In internet, he will open AWS website. In AWS website, he will take one server for rent and then he will show 2000 GB of data in that server. Guys, borrowing is not like physically you are taking this server to your house. Borrowing is nothing but by using internet, I will store my information in the server. So instead of buying physical server, AWS company contains so many servers. So this user will take one server for rent and then he will show data. And what this person use, only for that he need to pay rent, which will save our money. I'll give one more example. For example, let us say there is one employee. This employee want to do office work. For that office work, he needs system that contains 12 GB of RAM, 2 TB of hard disk, i7 12th generation, and that to Linux operating system. Purchasing this system is costly, and after purchasing system again you need to install Linux, which is time taking process. Now by using internet, this user will use any of these services, like he will open AWS website or Google Cloud website or Microsoft Azure website. By using internet, this user will open AWS website and then he will select a system with this configuration and then he will do that work. And how much time he use? Only for that he need to pay money. AWS, Google Cloud and Microsoft Azure. These three are famous companies that will provide cloud services. So instead of physically purchasing hardware or software or database or server, we can rent these resources from this website. Cloud computing services are classified into three categories. And the first one is infrastructure as a service. Shortly we call it as IaaS. And next one is platform as a service. Shortly we call it as PaaS. And third one is software as a service. Shortly we call it as SaaS. At first I will explain what is IaaS. Infrastructure as a service provides virtualized computing resources like servers, storage and network. You can get complete control over the infrastructure, but need to manage operating system and applications. In AWS, user took one server for rent. So whenever user took server for rent, AWS will provide only server, but installing operating system and applications is your responsibility. We are taking only infrastructure as a service. And second one is platform as a service. Mainly software employees will take this service from cloud providers like AWS, Microsoft, Azure, Google, etc. In platform as a service, company will not only provide infrastructure, but also it will provide operating system and tools for coding, testing and deployment. It will not provide complete softwares, but it will provide only few softwares that are required for coding, testing and deployment. So platform as a service is nothing but cloud providers will provide infrastructure and as well as operating system. And third one is software as a service. End users will take this service. End users are nothing but users like us. Software as a service provides ready to use software application like Gmail, Microsoft, Zoom, etc. over the internet. Users don't need to install and maintain any software, just log in and use it. Guys, whereas in IaaS, companies like AWS will provide only infrastructure, that is nothing but server, storage, etc. And whereas in PaaS, companies will provide both infrastructure, that is nothing but servers, and as well as operating systems. And whereas in software as a service, companies will provide infrastructure, operating system, and as well as softwares like Gmail, Microsoft Office, Zoom, etc. So just we need to log in and we can use. Guys, grid computing and cloud computing, both are different. In grid computing, multiple computers will solve one big task. And whereas cloud computing delivers services like storage, software, hardware, servers, etc. to users by using internet. Next I will explain what is biocomputing. Biocomputing is an area of science that combines biology and computing to solve problems using biological materials or models. Guys, we'll use computers in order to solve biological problems. Biocomputing uses molecules found in nature such as DNA and proteins. These molecules act as tools to help scientists develop computer programs that can perform various tasks related to biology. Guys, in nature there are some molecules. By using those molecules, software developers will write code in order to solve various kinds of operations related to biology. One important goal of biocomputing is to understand how diseases develop at a molecular level. This knowledge can lead to better treatment and therapies for various health conditions. Guys, by using this biocomputing, we can develop various kinds of new treatments for health diseases. Biocomputing enables the creation of new solutions in healthcare and other scientific areas by using biological concepts to solve complex computational challenges. Now, at present, various kinds of new treatments are available in order to solve various kinds of health diseases. And these new treatments are developed by using biocomputing. Next, I will explain what is mobile computing. Mobile computing means using small devices like smartphones or tablets to perform tasks such as sending or receiving information without needing wires. It relies on wireless communication like internet or cellular networks. Guys, in mobile computing, we'll use small devices like smartphones or tablets in order to perform tasks such as sending and receiving information. And it is not wired communication, it is wireless communication. And you can communicate from one device to another device by using internet or by using cellular networks. One of the example of mobile computing is using mobile phone. In olden days, we can just do only voice calls by using mobile. But at present, we can do so many things by using our smartphone. Like we can send messages, video calls, online meetings, and also we can use various kinds of apps by using mobile. People can do many things remotely like chatting, working, attending meetings, even when they are far away from their house or office. Guys, nowadays mobile technology is improving day by day, and mobile became essential for each and everyone. Next, I will explain what is quantum computing. Quantum computing is a new type of computing that could solve problems much faster than computers we use today. Guys, in quantum computing, we'll use powerful computers. The computers are much faster than our present computers. Normally, in our regular computers, we'll use small tiny switches called transistors. By using these transistors, we can control flow of electricity and as well as we can process information. Normally, transistors are present in your computer chip. So, how many transistors your computer chip contains, that much fast your computer will work. If transistors are very small, then you can place more transistors on your computer chip. That is why engineers are making transistors smaller. For every 18 months, by following Moore's law, engineers are making transistors very smaller. If transistors are smaller, then you can place more transistors on your computer chip, so your computer will work much faster. But now, transistors are already very small, and making it even more smaller is very tough. That is why computers are not becoming fast nowadays. This is why scientists are looking for new solution called quantum computing. This quantum computing works in different way in order to handle complex tasks. Quantum computers work in different way. In quantum computers, we'll use very tiny particles, and these quantum computers are based on quantum mechanics. And these quantum computers work much faster than even world's best computers. But these quantum computers are not available at present, still they are in development. Although scientists have made some test versions of these quantum computers, present they are not working well. Definitely quantum computers will be available at market in future, and they can solve very complex problems in much faster way. Next, I will explain what is optical computing. Optical computing is a new way of building computers that uses light instead of electricity to process information. Guys, normally in order to process information, we need to use electricity. But whereas in optical computing, instead of electricity, we will use light in order to process information. That light can be either visible light or infrared light. Normally in regular computers, electric signals are traveled through wires. But these signals are very slow than light. That is why if we transfer data from long distance, it will be very slow. So in order to overcome this problem, we need to use new technology like optical fibers. So instead of electricity, these optical fibers will use light in order to transfer information. And these optical fibers are mainly used for faster communication. And if we use light in order to perform calculations inside computer, they could work 10 times more faster than our present computers. Guys, optical computing is not available at present. Still, scientists are developing optical computing. So in future, if optical computing is implemented, then our computer works much faster than our present computers. Next, I will explain what is nano computing. Guess meaning of nano is very small. Nano computing means building computers using extremely tiny particles, much smaller than what we use today. In nano computing, we will build computers by using very tiny particles. Normally, our regular computers depends on silicon transistors. We call it as small switches. But whereas in nano computing, we will use even more small switches. And these switches are made up of carbon nanotubes. And these switches are even more smaller than our hair. These are three main challenges in nano computing, and the first one is size. In nano computing, we will use very small switches, so which is very hard to work. And second one is manufacturing. It is hard and expensive to create complex designs with small tiny particles. Guys, making designs for these smaller tiny particles is very tough. And third one is integration. Guys, in nano computing, there are very small tiny particles, and connecting all these particles is very tough. Researchers are working to solve these problems, and if they are success, then computers will be manufactured in very small size and more powerful than our present computers.